This is a 3D video aimed at helping people better understand the Sinter plant in Indonesia. And please understand that the equipment in the video might be different from the actual one at site. The sintering process is the first step of the iron-making processes and plays an important role to create iron ore that can be used in a blast furnace. The proper grain size of the iron ore required for a blast furnace is above 10 millimeters. Therefore, the purpose of the sinter plant is to process fine raw materials of below 10 millimeters into a coarse iron ore, ready to be charged to the blast furnace. Sinter plant layout. The sinter plant is classified into 3 facilities. First, the raw material handling facility stores and discharges the materials transferred from the material yard. Second, the sintering facility produces the actual sinter ore. Third, the crushing facility crushes, screens, and conveys the produced sinter ore. Moreover, exhaust ESP collects the dust generated from the sintering process. Plant dedusting ESP collects the dust generated in the screening and crushing equipment, and coke bag filter collects dust generated in the fuel crushing equipment. And in some cases, additional bag filters may have to be installed to collect the dust generated in the fuel and material storage bins. The start of the sinter process. Generally, in a sinter plant, iron ore is used as the main material. Serpentine, silica, limestone, blast return fine, and sinter return fine are used as auxiliary materials, and anthracite and coke are used as the fuel. Especially anthracite and coke, called the fuel, are processed in the fuel crushing equipment, and the fuel, which is not available for a blast furnace and a coke plant due to its small grain size, is crushed and screened there to be used for the sintering plant. Coke and anthracite processed in the fuel crushing equipment as well as pre-screened materials in a material plant are transferred to storage bins through belt conveyors. At this point, all kinds of materials and fuel are automatically fed into the storage bins by a tripper car. It is very important to mix raw materials and each auxiliary material at a proper mixing ratio in order to produce sinter ore required for the blast furnace. At the main control room of the sinter plant, CFW at the bottom of each storage bin is controlled in real time in order to keep accurate mixing ratios of each material. The raw materials and fuel, discharged at a proper ratio, are transferred to mixing drum by the belt conveyor. The mixing drum mixes each raw material evenly, adding moisture. The rotation speed and angle of the mixing drum are designed at an optimal angle for mixing the raw materials. The materials mixed in the mixing drum are charged into the re-rolling drum. The re-rolling drum granulates the materials, adding a proper amount of moisture to the material. The way of granulation is that coke, auxiliary materials, etc. are combined with iron ore as a center, rotating in the re-rolling drum. This is an important process to obtain permeability needed for the sintering process. The materials, which are granulated into proper sizes by the re-rolling drum, are conveyed to a surge hopper on top of a sinter machine. When the materials are charged, a shuttle conveyor is used to feed material uniformly in the surge hopper. At the bottom of the shuttle conveyor, a grizzly bar is installed to screen lump ore, because the lump ore causes a problem with charging equipment, and the lump ore screened here is collected at the bottom floor of the sinter machine through a drop chute installed on the side. There is charging equipment at the bottom of the surge hopper, and it consists of gates, a drum feeder, and a deflector. The gates consist of one main gate for controlling discharge rate and 3 sub-gates for feeding the materials evenly in the width direction to charge uniformly. Depending on the operating conditions, the opening of the gates and the rotation speed of the drum feeder can be adjusted, and the rotation speed of the drum feeder is automatically controlled according to the sinter machine speed and the thickness of the charged materials. It is a core technology for designing the charging equipment that mixed materials are evenly charged in a horizontal manner. Lump grained materials are forced to be charged onto the bottom, and fine-grained materials onto the top of a pallet. This helps improve permeability in the bed and make materials burn evenly. Before the mixed materials are charged onto the pallet, hearth layers are spread 100 millimeters thick on the bottom of the pallet, and the mixed materials are charged on the hearth layers. As a result, sinter ore is prevented from being melted and being stuck to the surface of the pallet during the sintering process. The surface of the mixed material is ignited by a burner in an ignition furnace. After ignition, the coke and the anthracite mixed in the materials are burned from the top to the bottom by suction pressure of the bottom of the pallet. The suction pressure is formed by a large suction fan at the rear edge of the gas main duct and is maintained during the whole sintering process. The fresh air of room temperature is continuously supplied to the upper part of the pallet by the suction pressure, and oxygen included in the supplied air accelerates the combustion of the ignited fuel and materials. At this point, the temperature of the fuel and materials increases more than 100 degrees Celsius, and they are combined each other, being melted, and then quickly cooled down by continuously supplied air. So they are cooled off like the shape of basalt, with plenty of porosity. While this process is in progress, the pallet continues to move the materials forward, which makes continuous operation possible. And during the whole sintering process, the exhaust gas temperature is measured at the main control room. At the moment when more than 70% of the sintering process progresses, the exhaust gas temperature increases rapidly, which means all the moisture in the materials evaporates and the sintering process is completed. This stage is called BTP in the sinter plant, and the sinter ore through BTP is not burned any longer and it is discharged, going through a cooling process. It takes about 30 to 40 minutes for the combustion layer on the top to go down to the bottom, and the pallet passes through BTP and reaches the discharging outlet. The sinter ore burned in the sinter machine is combined into a pallet-shaped one which looks like a large cake. A big mass of the sinter ore is crushed into a proper size at a hot crusher in order to be easily transferred. The crushed sinter ore is evenly charged into a cooler by a charging chute. The temperature of the discharged sinter ore is very high, about 800 degrees Celsius, and therefore it should be cooled down to below 120 degrees Celsius to be transferred to a screening equipment. It takes around 1.5 hours to cool the ore off using the cooler of the circular type. At the cooler, fresh air is forcefully blown into the sinter ore by a cooling air fan in order to accelerate cooling. Then the air flows from the bottom to the top of the pallet by an air duct at the lower part of the cooler. Dust is mostly produced during the charge in the cooling process, and most of the dust is collected by the plant dedusting ESP. After the cooler pallet rotates one round, the sinter ore falls to a discharge hopper. This is because one side of the pallet goes down due to the curved dip rail at the discharge outlet. The sinter ore stored in the discharge hopper is fed into the belt conveyor by a vibrating feeder at a constant amount. The feeding amount is remotely controlled at the control room. The cooled sinter ore is transferred to cool screens by the belt conveyor and then starts to be screened. At this point, the temperature of the sinter ore discharged from the cooler is measured in real time, because high-temperature sinter ore may cause the belt conveyor to be damaged, so the high-temperature sinter ore has to be immediately cooled off. The cooler sinter ore is conveyed to the cold screen, and the screening and crushing equipment starts. The screening and crushing equipment generally consists of 4 screens and 1 spike-type roll crusher in order to screen the sinter ore into a proper size to be used. The screened sinter ore of below 5 mm is transferred to the storage bin and reused for the sintering process. Among the screened sinter ore, the sinter ore of 10 to 15 mm is used as hardy layers required for the sintering process and therefore is conveyed to a hearth layer hopper through the belt conveyor. The sinter ore, screened in the screening and crushing equipment, is fed into the stock bin in the blast furnace through the belt conveyor. Before being fed into the storage bin, the sinter ore is divided into the lump-grained and the fine-grained sinter ore by a separating damper, and then they are separately fed into the stock bin of the blast furnace by a tripper. When the storage bin is full, the residual sinter ore is transferred to the sinter yard by the belt conveyor and stocked by stacker reclaimer. In preparation for emergency, the sinter yard can store an amount of the sinter ore which can be used for the blast furnace for 2 to 3 days. In case that the sinter plant has to be shut down, or planned repairs are required due to emergency during the normal operation, the sinter ore in the sinter yard is discharged by the stacker reclaimer and transferred to the stock bin again in order to keep normal operation of blast furnace.